Welcome, Honors Algebra 2, to the study guide. What an exciting time. I am going to break this up into a few different parts. So this section is just going to be 1 through 5, and then I'm going to do all of the special right triangle ones together, all of the identity ones together, and then the rest on another one. So we're going to start with number 1. This should be attached. So if you want to print this out, you can. If you want to do it on a separate piece of paper, you can. You do you. Okay. So number 1 says find the reference angle for 290 degrees. Now remember the reference angle, what that's looking for, reference angle is telling me basically you're looking for the acute angle. Acute angle means between 0 and 90 degrees. So reference angle must be between 0 and 90 degrees, or in radians, 0 and pi over 2. So whatever. But obviously 290 is not within that range. So what I do is I kind of graph it. I think about my coordinates and my quadrants here, and I think, where is 290? Well, we know, okay, this is 90, 180, 270, and 360. So 290 is about in here, right? So to find the reference angle, we always go back, and I'll zoom in a little because it's a little small there. We always go back to the x-axis. So what's closer, 360 or 180? And 360 is the closest. So remember, we always go back to an x-axis. And so then all we have to do is find this distance. And so we find that distance by subtracting. So 360 minus 270. We can just do that in our calculators. 360 minus 270 gets us 90 degrees. That doesn't make sense because I typed in 270 and I should have typed in 290. Who am I? Okay, so 290 is that angle. We're going back to that. I was looking at the 270 degrees here. So we would do, Miss Curry's calling to interrupt this video and I'm not going to answer. So 360 minus 290 is 70 degrees. Okay. So my reference angle is 70 degrees. We are between that range that we wanted to be in, so 0 and 90 degrees. We went back to an x-axis. That's super important. You always have to go back to an x-axis. Okay, so find the reference angle for negative 5 pi over 4. Now there's two ways of doing this. First way is by just looking at the denominator. I can just look at the denominator and figure out that I know that this reference angle is going to be 45 degrees. But let's say we didn't have that memorized. So what we'd have to do is we'd first have to get that positive. So we'd want to first find its coterminal angle. And if we really wanted to, we could also convert this to degrees. So I'm going to actually convert it to degrees because I know a lot of you guys prefer that. So remember to convert to degrees. We'd put pi on top and 180 on, or pi on bottom and 180 on top. and then I would use my calculator, and I would do -5 times 180 divided by 4, because I know the pi's are going to cancel out. I divided it by 4. Somehow it divided it by 4 twice, so it's -225. So the pi's cancel, and we get -225 degrees. So that's just converting it to degrees. And then to find now the reference angle, we'd first find the coterminal angle. Remember, the coterminal angle is basically the angle it's in its same position. So like at 0 degrees is the same position as 360 degrees. So it's like a full rotation. So to find this, we would just take this and add 360. So -225 plus 360 gets me 135. And then I can do exactly what I did up here. I can draw my quadrants. 135 I know is going to be in between 180 and 90. And so I'm going to write the 135 this time. And then we know, okay, we're always going back to my x-axis. So I would do 180 minus 135. And that gets me 45 degrees. Now, again, like I said, all of this work is basically optional. You don't have to do that if you memorize that 4. So the denominator, when in radians, will also tell me the reference angle. So I could have skipped this entire thing, like all of this work, and just seen 4 and gone straight to 45. If I saw 6, I would go straight to 30. If I saw 3, I'd go straight to 60. Okay, let's try 3. So if sine theta is equal to -rad3/4, and the angle measure is between pi and 3π/2, find secant theta. Now, why is it giving us this information? Well, what it's giving us there is it's telling me basically what quadrant it's in. This is like the whole purpose of this is it tells me what quadrant the angle is in. So, okay, if we think about, like if we come back up here, we know, okay, this is 0, pi/2, pi, 3π/2, and 2pi. So if the angle measure is between pi and 3π/2, that's telling me it's in quadrant 3. And so from there, I can start and use this information to draw my triangle. Now, when it doesn't give us the angle measure, that's when we have to draw our triangle and use the Pythagorean theorem. So I'm going to draw a graph, and I'm going to draw a triangle in quadrant 3. Now, remember, the triangle always goes back to the x-axis, and the angle measure is always at the origin. So if it's giving us sine theta is at -rad3/4, it's telling us, remember, sine is opposite over hypotenuse. So we think opposite is -rad3, which makes sense because this is negative. And then 4 is my hypotenuse. Remember, the hypotenuse is always positive. Okay, So then, and then this is negative because, it's a negative, either two ways of thinking about it, the negative here, or we know this is a negative value, it's going down. So then I have to find my third side length by using the Pythagorean theorem. So negative rad 3 squared plus x squared equals 4 squared. So negative rad 3 squared is 3. 4 squared is 16. Subtract 3 from both sides. Square root, and I get x is equal to rad 13. Now we have to think about the sign here. Is this going to be a positive rad 13 or a negative rad 13? And it's going to be a negative rad 13 because it's in the negative direction, right? It's over in the negative direction. So it's negative because it's on the negative x-axis. Okay, and then this one is only asking us to find secant. I did that because I wanted to make it easier on Go Formative. And so secant theta is the reciprocal of cosine. And so the reciprocal of cosine is going to be the hypotenuse over the adjacent. So in our scenario here, the hypotenuse is 4, and the adjacent is that negative rad 13. So I'm going to plug that in. It's going to be 4 over negative rad 13. We have to rationalize our denominator, so we have to multiply top and bottom by rad 13. And so we get 4 rad 13 over negative 13, or just negative 4 rad 13 over 13. And that is my final answer. Okay, so let's continue on with number 4. So number 4 says if secant theta is equal to negative 5 over 3 and cotangent theta is less than 0, find tangent theta. So first, this information and this information is now telling us what quadrant it's in. So it's telling us, okay, secant, which is the same as cosine. So cosine is negative. And then it's also telling us cotangent is less than 0. So cotangent is negative, which is also tangent is negative. So we think about on our quadrants, all students take classes. Well, it can't be quadrant 1 because not all of them are positive. So that's out. It can't be quadrant 3 because tangent is positive there. It can't be 4, so it has to be quadrant 2. And then it's giving us our side lengths. So it's telling us that secant theta is equal to negative 5 over 3, which secant is the reciprocal of cosine. So it's giving us the hypotenuse over the adjacent. So I'm going to use that information to draw my triangle in quadrant 2. Remember, your theta is always at the origin. And so it's giving us a hypotenuse. Now remember, the hypotenuse is always positive. So this is going to be a positive 5. And the adjacent is here, is going to be the negative 3, which makes sense because it's a negative distance on the x-axis. And then we just have to figure out our third side by using the Pythagorean theorem. So negative 3 squared plus x squared equals 5 squared. So we subtract 9 from both sides, and I get 16. Square root both sides, and I get 4. Now we have to think about the sign of 4. Is this going to be a positive 4 or a negative 4? And it's up, so it's going to be a positive 4. So tangent, remember, tangent is opposite over adjacent. So my opposite is 4. My adjacent is -3. So tangent theta is going to be -4 over 3. And that is it for 4. So we're just going to finish with 5 just because like we're going to I'm going to chunk it that way. So the last one we're going to do on this video is 5. So name the quadrant theta is in if cosecant is less than 0 and tangent theta is less than 0. So again, okay, it's telling us cosecant is less than 0. So cosecant is negative, which is telling me then that sine is negative. And then it's telling me tangent is also negative. So I go into my little acronym. All students take classes. All, it's not all because some of them are negative. It's not quadrant 2 because sine is negative and quadrant 2 sine is positive. It's not quadrant 3 because tangent is positive there. So it has to be quadrant 4. And that's it for this section. I'll pick up on 6 on the next video. So hopefully you guys can kind of pause here, take a break, do what you need to do, and come back and start with that whole chunk of like using your special right triangles. So there you have it. Have a good, nice little break.